Hi everyone, I'm Mate from Solarity, the sales representative for Hungary, one of them. And welcome to this day webinar. We are very happy that we are able to have this webinar with Daya, together with Daya. And I think we just saw CNI solution to Greece, and we are planning to do more of that. So thank you guys from Daya for being here. First, let me just share some information about Solarity and how we are working to help you with your ESS projects. So we started out in 2009 as an EPC company installer in the Czech Republic. And from 2011, we started to do distribution. By 2020, we stepped onto different markets other than Europe, and we basically became a global market participant. So obviously, our most important responsibility is to be a link between the manufacturer and you, the installer. And we want to take as much responsibility on us to make your life easier as we can. Please let me know if you can't hear me well or something is not right.
Yes.
We are presently on 4 continents. So we are active in Europe, obviously. We have an office in Prague, Budapest, Kiev. And we also have offices in Bogota, Colombia, Casablanca, Morocco, and Amman, Jordan. We are at about 60 employees right now and have delivered more than 2 gigawatts of quantity. You can see it on the map as well. We have our warehouse and our main office in Prague, or near Prague, but we also have some warehouses all around the world, as you can see, and we are active basically on all the markets. We have to be very active in everything to be different from other distributors. So we are always organizing trainings for ourselves to be more technical, to help you with technical questions. We are also happy to discuss financing options with you. I think we can say we are quite flexible with that. Also, we have some partner programs, so you can get better prices if you buy bigger volumes in one. We tend to organize trainings as well for our customers, and obviously we do logistics, and we support you locally almost in every country in Europe. So we started to focus more on the best solutions lately, and we are having a lot of trainings for that. The salespeople help you, supporting you with best projects, but also Solarity is also interested in co-investing in some projects. And for example, right now we are also cooperating with the Prague University in some technical questions regarding solar and BESS. Yes. So we are working together right now with 7 brands for only BESS solutions. As you can see there, Tecloma, Jinko. No, it's already 8. K-Star as well. Alpha, ESS, Samoda, Huawei, and Solax. We've been in the industry for 15 years, and we have installed a big project lately in Hungary. So it is okay to say that we have some expertise and experience in BESS projects. As you can see, we've installed a 10 megawatt hour big one here in Hungary, and we are actively developing a lot. We have a lot of quotations out, and our plan as Solarity is to focus more and more on BESS. And our main goal is not only to give you a product and offer a product solution, but we want to have a complete solution package for you. So we are in cooperation with banks to provide you financing solutions. We have good connection with aggregators who are providing EMS solutions, EMS softwares, different ones. We can connect you with those companies as well, and we are making sure that we are a very an essential link between you and the manufacturer. Obviously, we do commissioning as well. So inside Solarity, we have the approval to do cabinet solution commissioning. And for the bigger projects, we ask the manufacturer to do that. Yes, I've talked about these things. Obviously, we help you with project design as well, as much as we can, and doing our best that you don't have to deal with the details. So we are trying to take the responsibility and the work off your shoulders as much as we can. Yes, I've talked about energy management systems and commissioning, that we are providing that as well through our suppliers. Let me show you how we do it when we give a quotation for any BESS solution. So first we have a selection checklist that we send to you, and you can just write in everything about your project, so we know as much information as we can in advance before we give you a quotation. The minimal requirements are the rated output in kilowatts, the rated power, sorry, and the kilowatt hour of capacity that you need, or megawatt hour, it depends. Also, we have to know what application you would like to have. So will you use it for peak shaving, backup power, energy arbitrage, frequency regulation? You have to decide what you would like to do with the BESS project. Also, it is interesting for us if it's an AC or a DC coupled solution, and what space you have for it, and what are the constraints of the installation. So, and also what is important is the point of interconnection voltage, the POI voltage, which is essential to give you a quotation. Yeah, here we are talking about the POI voltage. So we have to know what transformer you will need, step up or step down transformer, and basically all our suppliers can provide that as well with the batteries, together with the batteries. As we are working together with 8 manufacturers, we can provide you with the more budget-friendly and also premium solutions. So any need you would have, we can provide a solution for that. Yeah, at the stage when we've sent you the quotation and you are seeing potential in that, and we start a negotiation process, then there on site and assess the more detailed technical conditions of the project. As I've already mentioned, we are collaborating with leading EMS providers here in Hungary and also for the whole of Europe. And we are making sure that the aggregators are providing the best solutions for you that you would need, tailor-made for you. I've talked about the financial support part. We are open to negotiate about the financial conditions of the implementation of the project as well, as we are in contact with a lot of banks. Yeah, so we are working hand in hand with the manufacturer when it comes to installation and commissioning. But as I've said earlier, our own technical guy, he's ready and capable of commissioning a smaller cabinet size solutions. Anything that's bigger than that, then we obviously ask the manufacturer's technical support team to help us with that, and the customer's EPC team. So we are working together on that. Also, it is possible to check our existing projects. So if you would like to visit the site that we've installed, we are happy to show you that, and you can learn from that as well. Obviously, we are not letting your hand go when the project is finished. So for O&M and anything that is after the installation, we are there to help you. And if any problem should come, we are trying to solve that as soon as possible. You can contact us here, you can contact me as well, but please let us know your questions, your comments, and at the end we will answer you, and hopefully we will work together in the future. Thank you.
Thank you, Martin. Please don't forget about the questions. We will answer them at the end and leave them in Q&A box.
Exactly.
Yes, and now please, we will be sharing presentation. Jeremy, yes, thank you. And Jeremy will show you the perspective from the DEA side.
Hello everyone, it's been a pleasure to have me here, and I'm from DEA ESS department. I will be here to introduce you to our product lineup, specifically focusing on the 215 solution. First, I will do a brief introduction to DEA Group as a whole. So we shall begin. This is some of our products within our product portfolio that we have for offer in the entirety of the EU market. We ranging from low voltage battery packs all the way to megawatt-hour level container solutions. We have everything covered, so we can provide you with comprehensive system solution. This is some of the products we have for offer. In the foreground are the hybrid inverters and battery packs, and backgrounds, they are the containers and high voltage racking system we have for offer. This is some brief information for DEA Group as a whole. This is our manufacturing facilities and some of the staff, just some basic info regarding DEA Tech Group. We actually been around for quite a while. We started our business in the early to late 90s. Started by being a supplier for some of the Western companies, and slowly and gradually we switched to inverter manufacturing and battery manufacturing. So we've been around for quite a while, for over 30 years, I think. And we are listed on the Shanghai Stock Exchange Center in 2021, I mean. We have quite a few manufacturing facilities all across China, and we are building one in Malaysia as we speak. The Malaysia facility will be ready for shipping, I think, in 2027. So we have Beilun headquarters here, and Longshan BESS manufacturing facility, that's where I am. And we have also special facilities for our cloud service teams that's based in Shanghai, and a couple more manufacturing the small appliances like the dehumidifiers and the HVAC. A lot of the HVAC model we use in our cabinets, they are built in-house. For some of our containers, and especially 430 and 215, we build everything other than the cells themselves. We build the BMS, we build the inverters, everything there's in-house by DEA. This is our inverter workshop that's based in Beilun. That's our headquarters. The entire manufacturing facility is highly automated, including the production line, the testing facilities, the logistics, a lot of the AGVs going around hauling stuff. This is the battery manufacturing facilities based in Longshan. That's where I am. Same story as the inverter department. Everything's highly automated. Barely any workers in the manufacturing line. So yeah. These are the certificates we've got for the inverter and the battery system. Basically, all the majority of the certificates you will ever need for our products to be sold in Europe is all there. Yeah. Our products are highly qualified, and EU market is like one of our longest running markets so far. We've been selling quite a percentage of our products to EU market for the past 3 years. And this is the offices and after-sale centers we have across the globe. As you can see, we are heavily invested in the EU market, and we have offices and after-sale service centers all across EU. Quite a few in Italy, Spain, Germany, Poland. So if there's anything wrong, shipping spare parts to your customer or to you guys won't be a problem for us. So now we go to the 215. This is just some of the specs for the system. I will not spend too much time on this because I will probably explain this a little bit much in details later. As you can see, I've put the I will start using the drawing function for. Is it not working?
I cannot see you.
Yeah, the comment section is not working here. Doesn't matter. I will use that. Okay, so I've got the pen. So on the left-hand side, that's not working. So on the left-hand side, that's the actual 215 cabinets. That's the exact model number we have for that. And on the right-hand side, we have the indoor counterpart. That's called the Boss B, I mean, plus the PCS system. If we are trying to understand 215, you cannot just look at this as a single piece of equipment. It's not a single cabinet. It's an entire batch solution. So what I mean by this is to achieve different functionalities for your application, say on-grid electricity trading, on-grid peak shaving, load shifting, that kind of purposes, you will need different parts. And for the UPS function, like backup power supply for your application for your facility, that will also need different components. So it's really a solution, not just a single piece of equipment. So on here, we can see all these battery packs. Actually, they are of the same model as Boss B. We take a 215 kilowatt hour indoor battery racks. We use the exact same batteries. We put them into an IP55 rated enclosure. That's how we get the 215. And on here, that's the 100K PCS. Same model as that one. Okay. And for the MPPT here, that's actually optional. It's not compulsory to have this, depending on whether you have this MPPT module or not. the letter S will be there or not. The S stands for solar. If you have the MPPT module built in, then it's the GS-G15. If it doesn't have it, then it's a G15. Some customer will choose to have AC coupled PV instead of our in-house DC coupled PV. That's completely fine. So that's the MPPT module we used in there. Now that is an interesting part. That's the STS module. This is the actual component to achieve the seamless transition between on-grid and off-grid operation. What I mean by this is if you want your 215 to work as a UPS for your factory, you must use the STS module. We have two also options for this. You can either use the STS module as it is. You can use this indoor IP20 module as it is. You can install this in your ACDB room, in your utility electricity supply room, electrical room basically. You can install the indoor module and use it. It's fine. We also, if you don't have the extra room in your electrical room to facilitate this STS module, we provide you with the MSTS 500-2-A. That's the STS cabinet that achieves the same function as the STS module, except for this one is an outdoor rated IP54 cabinet. Quite a lot to digest. So that's just some basic system introduction. How do I delete all this? Now this is our Boss G. That's Boss G. And that's our 50K series hybrid inverter. And this is our GEF60. Why am I showing this is as early as 2 years ago, when we first started going into the small scale CNI solutions, our first generation product is the Boss G. We first have this indoor IP20 solution first. That's 60 kWh per rack. That's a relatively small system. As you can see here, it's made up of 12 packs per rack, 5 kWh per pack. That's a really relatively small system. That's okay-ish for 2 years ago, but for now in 2025, it's relatively small for all kinds of purposes. At the beginning, we were selling the Boss G pretty well, and we got feedback from our customers that sometimes it's kind of tricky or it's even impossible to install battery inside of your buildings, especially in Germany. It's basically impossible to get any kind of permit from the government to install the indoor battery system. So they want something outdoor. So what we do is we take the Boss G, we take this whole stack of batteries, and we stick them inside of an IP55 enclosure. That's how we get the GF60. What it is really just the Boss G, but inside of a cabinet. You can find some similarities between Boss G F60 and our Boss B and 215. Same story. We are taking the indoor solution we have on hand, and we use this mature product and we put them into an outdoor enclosure. That's pretty much how we go from the indoor to outdoor, really. Why am I showing this? Is to show you the development logic behind all this. So this is the actual pack we have inside of our 215. This is the individual cell. That's a 220 mAh cell, which is each individual piece of this. And the BMU is in there. In the front, you will have a small access in the front to replace the BMU circuit if there's something wrong with it. And in the middle, it's air duct. Our 215 batteries, they are air cooled with an I think 6 kilowatt HVAC or 4 kilowatt. There will be cool air being pumped into the battery from the back by the HVAC, and the hot exhaust will come out from the front and be extracted by the HVAC intake. The entire circulation inside the electric compartment is completely isolated from outside. So the battery packs themselves, it's IP55. I mean, the battery pack, the compartment is IP55. So that's the packs we use. You can see these are naked, doesn't have the CCS on top. That is what we call CCS. You can find similar technology in EVs. That's called cell contact system. What it does, you can see this tiny piece of semiconductor here. That's what we call NTC. That's a negative temperature coefficient resistor. What it does is it takes temperature measurements on the cell. So we have multiple temperature sensors within our pack to monitor the cell temperature, so that if there's something wrong, we can send alarm right away at the first moment. So that on top entire thing is the CCS. What it does is it takes voltage measurement of each cell. We take temperature measurement of each cell so that we can monitor the health and the performance of our battery system, basically. And all of this data is gathered by BMU. And the BMU will send data to BMS. And all this data will be processed by our local controller. It's just the algorithm running behind it, just a little bit extra info for it. So this is what's actually, that's the main and the auxiliary power flow diagram, basically. That's what's happening inside our 215. That's our battery. That's our MPPT module. As I said, it's optional. And that's our PCS. So that, whatever it's on top, this is our main circuit. And whatever happens down there, they are the auxiliary power supply. Our system has triple redundancy built into it. It can take power from the battery. It can take power from the grid through PCS. It's not shown down here. There's a small lead acid battery down below to go through an DC AC converter to power some extra loads like fire system, signal sensor, that kind of thing. Also, this is the auxiliary power supply directly to the cabinet. We also take, if your facility has a emergency power supply, it can also power our auxiliary system. So we have quite a lot of redundancy built into our system. The lead acid battery will keep the fire suppression system running for at least up to 30 minutes if everything else is cut off. So our T15 is quite safe in terms of safety features. That's the MPPT and the PCS on top. I will not go too much of details into it. They're just there to do the conversion. Yeah, we use the same technology from our indoor models. All these STS, PCS, MPPT, they are developed by our good guys in the inverter department. We like to build everything in-house so that if there's some kind of say custom requirement, they want to add, delete some features, we can do that. That's the benefit of having everything built in-house. So it's easier to get the cooperation done between different parties, basically. So that's the HVAC, that's the thermal management in our 215 system. What's on top? So what's on top? That's HVAC. It's either 4 or 6 kilowatt. Don't quote me on that. I can check the spec sheet later. That only cools the battery compartment. Our battery compartment is IP55. But for our PCS, the PCS is actually, if you remember previously, the PCS somewhere down there. So it's forced ventilation. There will be a huge exhaust fan pulling cold air from the front and pushing the hot exhaust out from the back. The PCS and MPPT module themselves, they are actually IP65. So we make the electric compartment for the PCS to be IP54 only, because they themselves, they don't really need to be IP55. The PCS is watertight, so there's no point. And so that's why you can see on the spec sheet, the overall rating is IP54 because the rating takes the lowest number. And now we come to the actual hardware we put into our system for firefighting and suppression. I will elaborate a little bit here. So on top, there is a temperature, combustible air, and the smoke detector on top. These are the exhaust, and that is the air inlet. So when there's a combustible air being detected inside the battery cabinet, say carbon monoxide, hydrogen, that kind of thing, usually they will be released when your cells are experiencing thermal runaway. The inlet will pop open and the exhaust port will pop open. They are controlled by an electromagnet. And the exhaust fan will pull out the combustible air outside of your back cabinet so that to prevent an explosion inside. That is an aerosol dispenser. It's a cabinet level. Every single one of our pack, there's also pack level aerosol dispenser. So aerosol in our battery pack, aerosol in our compartment. If all this is still not enough to suppress the fire, there is water sprinkler. It's got the temperature sensitive glass inside. It's similar to the ones we use in our buildings. If this aerosol cannot suppress the fire and the fire starts to go rampant, the glass will break and your water will start spilling out. The water input is in the back. There will be a hose input to supply your water to the sprinkler. And also, this signal, this indicator will give out visual and audio alarm to your facility for people to evacuate. All this fire suppression system is to buy you time. As we've seen multiple news online or whatever, whenever if the cell actually starts catching fire, best you can do is to cool it down and buy you time. But rest assured, for the past 3 years we've been selling batteries, we haven't experienced any kind of a catastrophic failure. We only source our cells from the top tier cell suppliers in China. That's the firefighting logic behind it. It's multi-leveled fire suppression logic. Say if the situation only calls for extracting the fume, extracting the combustible air, and the system can still be salvaged, we will only open the exhaust port to extract the smoke and combustible gas, and we will not trigger the aerosol dispenser, and we will not trigger the water sprinkler so that the entire thing doesn't just go to waste. So it's a multi-leveled fire suppression logic. It's only when things get real serious, the final measure will be taken, basically. And I can show you a little bit of something. So I think you've seen it previously in the previous slides. That's what we call the GF60. It's our first generation CNI cabinet, and I will show you what the film extraction looks like. So as you can see, there's a manually triggered the thermal runaway inside the F60. And what just happened is there's an exhaust port. There's an air intake similar to 215. It's a pulling in fresh air, and there's an exhaust port on the top that's extracting the fumes outside the cabinet to prevent the explosion. And also, we've got something called the blowout panel to prevent a catastrophic failure. I will show you here. So what just happened is we manually triggered the multiple cells inside this GF120. That's a previous generation of 215. It's also an older model. What we did is we triggered a sudden release of pressure within the cabinets, and you can see there are blowout panels built into the back of the cabinet to release the pressure so that the cabinet itself doesn't become let's say a bomb, doesn't produce any shrapnel, and the release of pressure will not compromise the structural integrity. For installation, I will only cover very briefly about the installation, like the spacing requirement, that kind of thing, as you can see on the PowerPoints. For the actual installation, say if the customer puts down an order and they are very interested, we will provide you with the manual on the specific installation procedures for all of our components. Our 215 cabinet, they will require a foundation to be built so that the cables can be pulled down under, and there will be no hazardous cables hanging on the outside. All these installation requirements and all the specific details can be acquired through Solarity from us through the manual or instructions. And as for commissioning, as Solarity said, for 215, it's a quite complicated system. We have a comprehensive commissioning process. It's usually there will be a documentation and contracts to be signed for the commissioning. I will not go too much in details for now. It's just there for commissioning. DeYe staff will be there. We have a commissioning team in the field if it's at that stage. Now we come to the solution. As I said in the beginning, depending on the application scenarios, it's kind of complicated. So I will use a whiteboard for this. Where is whiteboard? Should I stop sharing or? I think I will just stop sharing for now and use the whiteboard for a bit, because I'm sure the function is there.
You mean in Zoom?
Yeah, in Zoom.
Okay.
I think the whiteboard is only accessible when no one's sharing.
I can see it now, so.
Yeah, so these are some of the handwritten stuff I did previously, just you can ignore that. We go to here. So these are the components we have. So that's our PCS, that's our MPPT module, and that's our STS module. We actually derive this from our hybrid inverter technology, actually. So inside of a hybrid inverter, I don't think I need to go too much in details like this. I will just tell you how to use 215 right away. So imagine you have a project like so. Let's say it's the simplest project on grid. Maybe you're doing load shifting. Or peak shaving, that kind of application. What you will do is you will have 215 AC coupled onto your low voltage bus. You can have up to 20 units down there working under one grid access. That's the transformer. So that's the grid access point. And you can have your load down here. Or you can have your string inverters. It can be DeYe brand, it can be other third-party brand, doesn't really matter. And there will be AC coupled PV, that's a load. Sorry. So what you will need is using the in-house. We sell this as a solution. The MS-EMS is one of our component to control the 215. If you remember, 215 has what we call an LC. It's a local controller. What it does is it takes all the info as an interface for the 215 cabinet, and that will actually talk to the EMS. And EMS, through the LV meter or HV meter for this application, just one low voltage meter that will do. Sorry. That will tell the EMS how much power we are pulling or injecting into the grid. If you, one moment. If you have requirement for anti-backfeeding, so you are not allowed to sell anything back to the grid, the EMS will take measurements at your grid access point. Say your string inverter is injecting too much power into your grid, like it's making too much power, and the direction of the power flow is starting to change. The EMS will tell our 215 to start absorbing as much as possible to absorb all of this excess power into our battery. That's one of the functions we have for the EMS. Our EMS has all the functions that you have with our hybrid inverters, time of use, peak shaving, all that kind of good stuff. Everything you have with our DeYe hybrid inverter, it's also here in EMS. Even though they're developed by different teams, we share the same technology here. So that's on-grid operation, the simplest one. Now we go to something a little bit trickier, which is on-grid, off-grid transition. Seamless transition with the STS module. One thing to emphasize, to make sure you guys are not misunderstanding, STS and ATS, they are complete different things. They cannot be just called interchangeably. They're different things. STS is called static transfer switch. What that means is, from the point of view of the load, whatever happens at the grid side, the load doesn't experience any fluctuation in the power quality, because the moment the grid goes out, our 215, our PCS will start supplying the load within 20 milliseconds of switching time. That's why it's STS. From the point of view of the load, everything is static, nothing has changed. But for ATS, it works on complete different strategy. For ATS, it's like a time delay switch. Like when the grid goes out, the ATS will try to reclose the breaker a couple times until the generator has started or something. So that's just a different terminology here. I'm just getting that clear. So that could be our STS module or cabinet, up to you. STS cabinet is slightly more expensive. The STS module is cheaper, but will take up more space in your electric room. So that's our 215 cabinets. up to 5, that will be a load. And also this generator input, I'm not drawing here. So for this, you will need EMS for every single one of these STS. 得业 EMS. You also need a meter here. That is telling EMS how much power we're pulling. And that will control this entire thing. It's working as a small system. The moment the grid goes out, the STS will cut the grid side relay, and all of this is operating within its self-contained small system controlled by this EMS. And you can multiply this. It's not multiply. I'm not too familiar with this platform just yet. So you can multiply this indefinitely as long as you have enough transformer capacity. So all this is a self-contained system when the grid is gone. So you can multiply this indefinitely as long as you have enough budget and enough capacity left in transformer, basically. And yeah, that's 2 of the most commonly asked operation. And people also, it's our 215 has what's called a black star function. Our 215 can sustain itself. It's not all due to 215. It's really thanks to the technology given to us by our good people in inverter department. So for our PCS, there are 2 main operating mode, what's called a VF mode and also a PQ mode. So VF mode is the grid forming. So that's the mode the PCS will be working at in off-grid operation, in microgrid operation. So the entire thing is completely off-grid. The only thing you have is maybe generators and only used when necessary. So our PCS will be working in the grid forming VF mode and taking power from solar, from our MPPT module. We highly recommend you use our MPPT module. High efficiency, that's one thing. Another thing is AC coupled PV will not be able to charge our PCS when off-grid. That's one of the drawbacks, is because most of the string inverters, they only work in PQ mode. That's the grid following. Most of the string inverters only works in the grid following mode. And if our battery is low on SOC and our PCS wants to charge the battery, it cannot sustain the VF mode. So nobody is providing a stable VF source for the system to form a grid. So AC coupled the PV has one drawback. It cannot charge our system when off grid. In this case, what you need to do is to start up the generator first. The generator will provide a stable VF source for your system to form a grid. And our PCS can work in PQ mode to charge our battery. And your string inverter can also work in PQ mode to supply electricity to your PCS. And your diesel generator will only be there working at very low throttle or like idling, just as a VF source, nothing else. It will save you a lot of fuel, but you will need the generator to be working to have your AC coupled PV to charge your our 215. Yeah, that's quite a lot of rumbling. I think that's pretty much all the application scenarios, the most common ones here. I will stop for now. I think that's enough for these slides. How do I exit? How do I exit the whiteboard?
Sorry, I'm trying to do something.
I'm clicking. Oh, good. Thanks.
You're welcome.
We'll go back to the slides. I think we've been deviating for quite a lot. So all this, they are just more beautiful CAD drawing of what I just said. So I will just quickly go over it, because there's another selling point that I want to introduce you to, which is our cloud services, which is very strong. These are the slides for it. I will show you what it looks like in real life. So this is our DEA Cloud. This is EU data center. We have one for North America, one for EU, and one for India. India is taking care of the Middle East and stuff. But for your Czech and Germany, that kind of thing, you will be using EU data center. If some of your clients are familiar with DEA products, they must have experience with our cloud services. What I want to show you is we are implementing a new feature called DEA Copilot. And what it does is it will try to estimate the electricity price for the next 15 minutes. Because in Europe market, for the electricity trading, they trade on a basis of every 15 minutes. And what that can do is I can show you a couple projects running right now using the DEA Copilot. I'm not quite sure if that's in Germany or somewhere, but it's one that's using the DEA Copilot. So all the functions, all the settings you can change locally. It can be accessed on the cloud. It's quite small. It's a quite small hybrid inverter. It's 4 kilowatt peak. That's a very small solar array. But I will just use that as an example. So all of this data, it can be read on the cloud on the fly. You can also change settings to the hybrid inverter or to EMS in our case with 215. So that will grant us the access to change the settings to the inverter, which I will not be doing because I don't have the permission from this client. I'm just using his site as an example. So all of these settings that you can see on the LCD screen of a hybrid inverter, it's all accessible on the cloud. Same for EMS. So I accidentally closed it. I bet. So previously, if you have experience with DEA products, you will know our hybrid inverter has pages of settings and options you can choose. Sometimes it's a bit confusing and people just want to use it. And what you can do is now you can enable AI DEA Copilot. What you can do is you can see it's estimating the electricity price for every 15 minutes. And depending on your control strategy, so DEA Copilot, that's everything's done by the algorithm. But manual mode is the old way. You set things manually, charging, discharging strategy, time of use, that kind of thing. That's done manually. That's the old way. The new way is the AI Copilot. And what can happen is you go into the settings, the maximize self-consumption. That's what we call a very conservative strategy. And what that does is the system will try to maximize the battery storage as much as possible so that if your grid goes out, your system is ready to go to power your load in off-grid operation. The application scenario I can think of is in Ukraine, like their utility grid has been destroyed, and their grid is unstable. What they want to do is use the maximize self-consumption so that when the grid cuts out, they can still use their electricity, use their equipment in off-grid operation. This is 50-50. It will try to save some energy in your battery and sell some to the grid to make some returns. And the maximized earnings is the most radical. What it does is it will estimate the next 15-minute price. If the grid price is very expensive, it will try to discharge all of your solar and your battery into the grid to sell them away to make the most money in return, basically. And if we see some values here, we can see that for this very small system, a 4 kilowatt peak system, let's see how much it's made them so far. So yesterday it made them 1.44 euro. I won't say it's a lot, but it's a very small system. So for last month, it's made them 27 euros. It's enough for some grocery shopping, I would say. For last year, it's made them 600 euro. So it's quite significant with the AI Copilot. So yeah, that's pretty much it. We have a couple projects running in China and one in Malaysia. That's one site that we've commissioned in Malaysia. They are doing some O&M on the site right now. I think they're replacing some parts there. But yeah, we have a very comprehensive after-sale services and the commissioning program for our customers. So yeah, I think that's enough rambling for now. And yeah, that's pretty much it from me.
Thank you so much for showing all these technical details and practical insights about the solutions showed today. And we can now take a look at some of the questions that came in during the session. Can you see the Q&A block? Sorry, I can't hear you.
I will go through them one by one.
Okay,
So how
thank
do you
you.
handle cooperation with other branch string inverters? As I showed previously, if it's on-grid system, our EMS, depending on whether you can sell back to the grid or not, it will change the charging or discharging strategy of our PCS to try to absorb the excess energy or try to sell into the grid when it's expensive. Or if there's another way, our EMS, we provide an open sourced Modbus TCP protocol to our customer. And if they like, or if it's a huge order, like they're purchasing 20 cabinets in bulk, we will actually do it for them. We will do what's called a protocol mapping. We will establish the communication protocol between the third-party string inverter with our EMS, so that our EMS can actually communicate with the string inverter to control the power generation. So far, we've only done the protocol mapping with the in-house string inverter so far. But if there's a need, we can do that. If something go wrong, what we can support, what we can expect. Depending on what level of things going wrong. Say if it's a simple fix, say you have an NTC sensor that's faulty, it's triggering level 2 protection, it's cutting the power output of the 215. We will first do remote diagnosis. First, we can see what's going on. If we can pinpoint that it's only an NTC fault, meaning there's a temperature sensor wrong in there, we can provide a hot fix, which is bypassing this faulty NTC sensor first, and we will ship a spare part. If NTC is wrong, we can ship you new NTC, new sensors, or new BMU to you so that you can replace it. We have after-sale service staff in Poland and in Germany, DEYE staff. Depending on the after-sale O&M program you purchased, it's either paid by us or it's paid by customer, depending on what kind of program you purchased. So we can replace some small parts, but if it's something is gone horribly wrong, say the PCS is completely shorted and this like the thing won't even boot up, the ARC is short, the thing just will not start up. We will send the service team right away on site with, say, if you can tell that PCS is not working, the ERC is fried, the BMS is fried, we'll just bring spare parts with us and we'll replace it for you if that's triggered our warranty. So I mean, DEYE is a pretty big company. It's a pretty big group. We have our reputation to uphold. So if there's something wrong, we will send out our team to replace the parts for you. If it's horribly wrong, but if it's just some small parts like BMU, you can replace it yourself. Or maybe Solar, we can do some training with Solarity staff and they can replace it. It's really simple. Just open the cabinet, replace a circuit. That's it. What's the maximum power of STS? 500 kilowatt. Does STS for both PC and for NC different? I've shown that the STS cabinet is called the MSTS 500-2-A. The STS module inside is identical to the one used for boss B. They are same. Well, as I said, the way we develop our product is we first develop a mature indoor solution first. Then we will use the mature product and we put that into enclosure so that we are not jumping too far. We don't create too much of a hassle when integrating different parts. Could we install? Yeah, yes and no. For STS module indoor, the STS indoor modules, you can parallel AC couple them up to 4 units in total, giving you 2 megawatt of rating total. But if you're using the outdoor cabinets, it's only limited to 500 kilowatt, and you cannot do AC coupling between them. Reason is some hardware software limitations. You cannot do that basically. But we are developing what's called a TS1000 and a TS2000 in the future. As the name suggests, it's taking multiple STS modules, put them into one single cabinet and making it bigger. So look forward to it, I guess. Built-in meter for load and first, our STS has 4 terminals, 4 ports, grid, gen, load, and PCS. All of these 4 AC ports, they have built-in CTs to measure the power flow, basically. Yes, if you want our EMS to control the power flow, you will need the separate meter, but we provide them as product. It's RDL 400 series. It's when the sales are placing down orders for us, that will be part of the BOM. That will be part of the things for sale. We sell low voltage meter and high voltage meter both. C rate for battery. It's what is it? It's 168. Let me just check it. I think 0.6 C. Yeah, it's a 0.6 C system. The maximum is 0.6 C, and it can jump up to, I think, 1.5 or 1.7 times the rated power for up to 10 seconds. We are matching the performance for PCS. Our PCS can do what's called a burst output. It can instantaneously deliver 1.7 times the rated output. 100K PCS can do 170K for 10 seconds. Our battery is trying to match that. Have you established connection with EU brand EMS? What brand has been already tested? Not so far. We are looking for partners, so we are open for suggestions. But our MS EMS, they have comprehensive certificates for cybersecurity, that kind of thing. I can show it later. It's not, I can't recall it on top of my hand, but we've done the cybersecurity certificates for our EMS so that it can actually work in your market. Third party require. That depends. As I said, we provide what's called a protocol mapping. We will provide an open source Modbus TCP protocol to you. We can do mapping here by DEIA, or the customer can do mapping yourself or with the inverter supplier. Someone has to do it, but at the end of the day, our EMS will work as an interface to provide information, performance specs for our system to outside. Our EMS will be the interface. You can read the information, you can give commands through the internet cable, the Modbus TCP cable, basically. Complete discharge in cold temperatures, can they be started from the grid, PV, or generator? When starting from the grid, does HVAC start first, then charge? Oh, that's like the worst case scenario. It's a complete black start, cold start. That I need to check. Because usually how it happens is the system will be operating already and the temperature goes down. Yes. If I go back to the hardware is there. It's just a matter of the operating logic. If we go back here, that slide, and how do I zoom in? The HVAC, it's on down under here, and you can see that we have supplies. If you have grid, the PCS will be able to power your HVAC to raise the temperature inside the cabinet and start slowly charging your batteries. And yeah, it can come in through PCS. It can come in through the auxiliary power supply. If there is grid, it can start all HVAC, and the thing will slowly raise its temperature and come alive from the dead, I guess. The hardware is there. Whether the software supports it, I need to double check. But if the hardware is there, I don't see why the software will not allow for it. Because the HVAC works under AIRC, it's not under BMS or battery. So the AIRC, the local controller, will actually decide the operating logic for the HVAC. Or guaranteed percent remaining capacity, 70%. 70%, 6,000 cycles, I believe. The warranty can be extended. I mean, by default, if you just pay the default price, you will get a default warranty, which is 6,000 cycles, 70% EOL, and 10 years of warranty. But if you purchase our extension program, you can get it longer. These detailed numbers, I cannot recall on top of my head, but if you are interested, well, we can talk to the after sale service and after sale team and get a specific number for you. Asymmetric load. That will be 100%. Our PCS can do what's called 100% unbalanced output. So it's 100K PCS. Or you mean single phase? What it can do is for 100K PCS, single phase, every single phase can do 0 to 33 kilowatt of output, regardless what the other two phases are doing. Our phases, they're working independently of each other. Three-phase inverter, that would be 50 divided by 3 plus a bit more. I think 5% more. It can do 50 kilowatt divided by 3, that's per phase, times 1.05, 5% more. Unbalanced output per phase. Anything more than that, you might trigger the AC overload on the grid or load side. You have utility batteries available. Yeah, I know this session is focused on the 215, but we have bigger containers in the oven. We are baking it right now. We are trying to get that ready for the first quarter or second quarter of 2026. If you have a look at here. So this is our utility scale solution. That's a 2 megawatt hour, 1 megawatt power, all-in-one AC BESS. That's a 24 container. And what it does is it's air cooled. So it's a 24 air cooled container. And we have AC, we have a liquid cooled solution as well. That's a 2.25 megawatt PCS container. It does nothing else but the power output. That's every PCS and BBT module. They're all inside here. And that's our battery container. That's a 4.3 megawatt hour liquid cooled battery container. So we are developing this. At which stage, I'm not quite sure, but the R&D promised us it will be ready by second quarter of 2026. If I have unstable grid with high of sensitivity on the low side, can we supply a load with stable VFL? Use grid again only to charge. Yes, we can do that. In that case, I highly suggest you use the STS module and also the Deye in-house MPPT module, because if there is unstable grid, our STS is constantly monitoring the power quality on your grid side. If the grid quality is dropping out of the threshold, say too much of frequency drip or too much of a frequency drop, voltage drop, or there's spikes, the STS will prematurely disconnect the grid relay to isolate the grid, and the system and the STS will first talk to EMS. EMS will talk to ARC. The ARC will let the PCS know that it needs to get ready to switch from PQ mode to VF mode. Can I place TS500 and EMS on one location, MS another location of same factory and space? Sounds doable, but in this case, your EMS will need to switch to the the optical fiber instead of the RJ45 standard copper wire. Sounds doable, but you will need to let me see the single line diagram of the facility and how you're gonna do it. 200 meters, there will be some power loss in the low voltage AC side, but it's not substantial, so I think it's doable. Will you import energy price for Copilot automated for? Yeah, that's one of the function. If I show you here. So I'm not quite sure where this is based. Let me have a look. I think the entire European Union or the NATO. I'm not quite sure. It's the EU, the Western, Middle, and Eastern Europe. As long as you're integrated into this EU electricity trading market, we can do it. It's in Netherlands. Okay, it's in Netherlands, and so they are importing and guessing the electricity prices for every 15 minutes. You can see the exact algorithm, the magic behind it. It's all done by our good people in Shanghai cloud service team. They are the heroes behind this. So that's a yes. We will automatically not only import, but will also make a guesstimation on how the price will be in 15 minutes. Very existing solar farms that power some inverters. So that will be an AC couple solution, yes. That will be AC couple solution with our EMS, and our EMS will tell the BESS when to charge and when to discharge. Compartment having HVAC cooling on top. Will you please tell the airflow directions when any services? That will be part of the O&M menu. It will be included in there, like how often you need to inspect for the filters, how often you need to check for leaks, how often you need to check for compressor, that kind of thing. It's all part of the O&M menu. That will be delivered. That will be provided to you once you put down the order. I mean. Yeah, that's HVAC on top. That's a 4 or 6, I can't remember. 4 or 6 kilowatt of HVAC on top for the battery compartment. The airflow directions, it's I think it's best if I draw it. So I will be using a black. Yeah. I will try to make it 3D. My drawing sucks, honestly. So imagine that's the battery. in there. That's battery. As I already showed you, each pack has got air duct in the back. There will be an opening in the back. So the HVAC is this is the input for HVAC. The HVAC is pumping cold air into the back of the cabinet, and the cold air will be pulled in the front through the air duct with a fan in each battery pack, and the hot air will be extracted into the front of the cabinet, and there's an air intake in the front. The hot air will be pulled away by the HVAC and cool down through the radiator and put into the back again. It's a closed circulation. Which smart meter model do you use? Since I'm no longer sharing the slides, I will just show the files in my laptop. So these are the model of a meter that we have for offer. I mean, that's like part of the product solution. We provide that. The menu is in Chinese, I'm sorry, but yeah, that's the meter we provide. And we are open for suggestions for other meters, compatibility pairing. Like if there's a big enough order, there's strong incentive for us to invest the R&D resources into. Anything's possible basically, because we have the resources to develop those. Any calibration for battery pack modules required? Not that I can think of. If you just commission the packs first, usually it will do a charge. It will charge up fully to 100% SOC, and then the SOC will be calibrated at that point. Our cell goes between 2.85 and 3.6 volts. The system will calibrate itself to be 100% SOC when the cell voltage level has gone up to 3.6 volts per cell. No calibration needed. Everything's done automatically. As long as you are running full cycles every couple of weeks, that will be fine. Round trip efficiency advertisement is 88%, but we have achieved 92% so far. Let me pull up the site. We've been running in China for 1 year now. Yeah, I can exit. So I will be showing you couple sites we got running in China. We try to play it safe. We first launched projects in China that's close to our factories first, so that if there's something going wrong, we can just go there and fix it right away. Where is it? So that's one we have running. So let me check. So we have been charged. This site has no solar at all. It's just doing the load shifting by making money in the pricing difference between on-grid and off-grid. Between on-peak and off-peak, sorry. So we have discharged. Am I sharing screen?
No, not. Okay, you started sharing. Yes, it's visible now.
So we have discharged 1.68 gigawatt hour by charging 1.82. So the actual efficiency is closer to 93%, even though we advertise it to be 88%. We like to be conservative in terms of the performance. So on the spec sheet, you will see 88% by us, but in reality, the sites that have been running for 1 year, it's telling us 92%. Czechoslovakia. Not quite sure what that's supposed to mean, but if you're talking about whether our Copilot has implemented the grid standards in our Copilot, not too certain on this, but if it's in European Union, it will be. In decomposition, functional table cross-section in data understood. If you're talking about all these documentations, send us an email. We will try to get the right guys to reply to you, basically. Yeah. I think that's pretty much all.
Thank you, Jeremy, for such detailed and engaging presentation, and also for all the questions answered today. And we really appreciate your time and our great partnership with DEA and Solarity. Also, big thank you to Mate that he represented Solarity today. I think it's all for today's session. Again, thank you so much for joining us, and we hope you found today's webinar useful. The webinar will be recorded and it will be on our YouTube channel soon. And if you have any further questions, please contact us, contact our sales team. You can find all the contacts in our websites for all the countries. So thank you. Have a great day and see you next time.
Bye-bye.
Thank you. Bye.